system. So how does gravity affect the human body? So the vestibular system is responsible for the brain understanding the body's position and balance, especially when there's a lack of visual cues. So like when there's light or something telling you like you're facing forward, you're facing backwards. The vestibular system is split into two parts. Both are within your ear and are situated to be able to understand the body's positioning when in like 1G or on Earth. So the otolith organs, which is the first part, allows us to sense the direction and speed of the linear acceleration and our head tilt. So like if you're going forward or backward in a car, stuff like that. And then the semicircular canals, which allow us to sense the direction and speed of angular acceleration. So a sharp right, sharp left turn. Is the human body affected by microgravity? Because the vestibular system is situated to work with the body on Earth, microgravity causes the system to not be able to function normally. When in microgravity, the vestibular system will send misinformation to the brain, causing major disorientation. So, a lack of coordination and stuff like that. How can humans prepare their body for space travel? Astronauts go through a series of training to become accustomed to work in microgravity climates. Part of training is working in the neutral buoyancy laboratory, which is a giant pool where they practice full-size simulations of what they would be doing in space, and like they go in like full spacesuits and everything. And at times, astronauts could be spending up to 7 hours underwater. What research is being done to prepare for future space travel? NASA has developed tests to measure how much the body changes when not only traveling in microgravity, but traveling between gravity fields. So, like, traveling from Earth to the moon to Mars and, like, in between those. NASA's also working on analyzing your body's changes in weightlessness once returning to Earth. And once you return to Earth, they conduct fine motor tests and functional task tests, which is balance, and they all help track the changes your body made while in space. What atmosphere and gravitational changes directly affect the system? Gravity is responsible for giving the otolith system information on the body's location and position. So when removed from gravity, the system automatically loses its sense of position, so basically it loses function until accustomed in space. And during liftoff, astronauts feel 3 times the amount of gravitational pull than when on Earth. Oftentimes they report having a false sense of pitch during this time, so how like they're positioning, if they're positioning on a steep up angle, steep down angle, stuff like that. What changes can be expected of the human body while in a microgravity environment? There's initial loss of spatial perception that happens as soon as they leave Earth's atmosphere. And during the 2 to 4 day adjustment period, astronauts also experience major motion sickness because of the lack of ability to understand where they are and how they're moving. So that'll be like nausea. A lot of times it'll be vomiting and stuff like that. They like what you would experience on like a roller coaster. They also may experience a lack of coordination and knowledge of limb positioning, and that just goes along with the body's sense of perception with gravity acting on it. So the lack of gravity means the lack of limb positioning or knowledge of limb positioning. How long does it take the system to return to normal once back on Earth? When re-entering the Earth's atmosphere, the extra G-forces give them an increased sense of acceleration sensation. Astronauts tend to report clumsiness, an inability to walk in straight lines, and maintaining upright posture, an inability to maintain upright posture for the first few days back on Earth. And then after a few days back on Earth, the otolith system re-engage with the astronauts' bodies, and they're able to readjust and go back to living like normal. And those are my sources.